Thank you very much for coming. Well, it's very nice to have you all here. I'm a data analyst at BigFi, right? And I'll show you a little bit of what we've been working on, what I especially have been working on in these past months, right? We'll talk about data quality and how we're trying to break this 80-20 cleaning rule we have in data science, right? Quickly, I'll talk about me and about what we do at BigFi. I'll introduce you the problem, how we are approaching it, our first achievements, next steps we have in mind, and then we wrap up. Well, there are two things I'd like you to know about me before we dive into the presentation. The first one is, David said they welcome beginners, and then here I am, right? So 1 year and 2 days ago, I started on this journey of career changing, right? I had been working in education for 15 years. I considered myself successful, but I wanted a challenge, I wanted to pursue a dream. And then I joined a boot camp, right? And today I'm here, so it's just been 1 year, right? 1 year since I started learning to code in R, okay? I won't be talking about art today, so things have changed. I was hired in March by BigFi. It's been amazing. These guys, I wish you could see them. So we have Sergi right there. I'll be talking about them, and Alberto, who are great mentors. I'm very pleased to have one of my mentors from the bootcamp here too, so thank you all for being here. That was the first thing I wanted you to know about me. The second thing I want you to know about me is that I'm kind of a needy speaker. So I'll be very glad if you nod and smile and laugh at the one joke I have, okay? About BigFi. Well, I have to say it's an amazing journey, right? We have to thank Barcelona for the venue you see today. We are right there, usually, right? When we are not here presenting, and we'd like you to join us for beer and pizza later, right? What do we do there? Well, if you understand our clients and what we provide them with, you'll understand more or less what we work on. Our clients are retail physical shops or chains of shops, okay, more specifically. And what we provide to them is we go and collect their data, especially their tickets data and everything that is related to their tickets, and we provide them with a platform where they can see their KPIs. We provide both descriptive and predictive analytics, okay? So we do a lot of cool data science. And I'll tell you a little bit of this journey. Now, if we look at things from the inside, what we do is when we connect to these clients, we are connecting to a bunch of point of sales, right? So these are our shops of a client, for example, and this data from the point of sales comes to their database. I'll say we're connecting to our client SQL database. That's my main focus today, but we don't only connect to SQL databases, right? Depending on the client, we'll connect to their APIs, whatever they have. Let's focus on SQL database today. What we do is then we bring this data into an AWS S3 and then into our database. And from our database, what we do is we run our algorithms and cool data science things, and this is all available for them in the front end. What is the problem? Well, we've all heard this 80% of the time data scientists spend on cleaning their data, right? The problem is that this raw data we connect to is wild, right? And data wrangling is really time consuming. And this is how we feel a bit, right? Sometimes. Okay, so this takes us 80% of the time, and that's what we're going to be talking about today, okay? Of course, when I say 80% of the time, we're also talking about pre-processing the data, so we get to the machine learning algorithms and everything, but here you can clearly see that, well, this takes much of our time. So we've been thinking about what to do, because there's no point in training machine learning algorithms if your data is not good enough, right? So what is our approach to reduce this time? So round one of this data wrangling we've been doing. Round one consists in in validating what comes from origin, what comes from our clients, okay? So our first step is this script in Python, which is the raw import, right? So we bring raw data from our client into S3, that's a copy of their data, cool. And now, once we have done that, we want to have a look and understand what kind of data this client has, meaning how good is their data, right? Instead of doing it manually, that was kind of a spoiler. Instead of doing it manually, we've been trying to automatize that, okay? Something else you should know about us at BT. We have a thing for tickets, right? This is what we do. So if you want to talk to one of us at the end of the day and you don't know how to approach us and you happen to have a ticket in your pocket, this is a great conversation starter. Look, I have a ticket, want to talk about it, right? Let me tell you how these tickets become our tables in the database, right? So this is a ticket you can get at a supermarket, for example, at a fruit shop, and this is what our ticket table will look like at BT. Okay, so from this ticket we get an ID, a timestamp, we have the total billing here, customer, if the shop collects it, because remember we're talking about physical shops. Shops don't keep track of every customer that purchases them, right? The seller, if they keep track of it, payment method, and that's it. Now, besides that, we have another table, which is ticket product, where we collect these, each line of these tickets. So we also have the ticket ID, so we can relate to the ticket table. But then we have the product, quantity, billing. And then, why am I telling you this? Because, well, this is one of the first things we look at. So this first script, which does the origin validation, what it does is, we know, or we always want to look at our client's data and check if billing from a certain ticket matches with the billing in ticket product, right? So the sum of this billing ticket product has to match billing in ticket. So this is something that we don't have to do manually anymore, right? What else do we check? So this is only one of the example of data consistency checks we do. We also want to know which of our clients are collecting data, how they are collecting their data. So do they collect customer IDs? So how many of these tickets have a customer? How many of these tickets have a seller ID, have a payment method ID? This is another validation we do. And then finally, what this script gives us back is an overview of some of the tables that interest us the most. So the length of the table, how many of the tickets, or the percentage of tickets that has been zero, that has negative billing, and so on. So these are things that are very specific for us, that we always want to look at, and there was no point in just sitting and opening a Jupyter notebook every time you have a new client, right? So this was round one. Now, what do we do next? Well, round two is this internal validation. So, really glad to say that the person who's behind this is here today. I'm calling it internal validation, but I'll tell you that internally we usually say, let's run a Moises, who's the guy who wrote the script, right? So can you please run a Moises on this? And that's what we do. So we have the data in S3. We transform it to bring it to Bitfeed, right? In this transformation step, bad things can happen, I'll say, right? And then we need to validate it. Instead of validating it manually, we have a script that does it. What does it look for? Well, it looks for duplicate entries. It checks that the sum of the shop sales matches the sum of sales by product and things like that, right? So a series of checks to avoid doing it manually. And then finally, there's what I call battle zero, okay? Actually, all of these steps, they can only happen once we have this battle zero. What is this battle zero? Well, every time we have a new client, that means we may have to go through all these steps. Well, we will go through all these steps every time we have a new client. And the point is, we need to understand what is in their database, what is this data that is in origin, and what we need to collect from origin to bring to Bitfeed, okay? The point here is each shop or each chain works with different points of sales, which means they have completely different schema databases, right? Database schemas. So every time we have a new client we have never worked on or a new point of sales database, what we have to do is understand everything that happens here. So for example, there's this new client, we look at their database, you say, okay, do I need everything here? I don't need everything here. So we go and we need to decide or to understand which of their tables are important for us. Which ones do we need to collect? Which ones are we going to bring to Bitfeed? Once we know these tables, we need to look and find each column. Which columns do we want and which transformations do we have to make to have them at Bitfeed and to be able to deliver our product, right? This looks simple, but if I'm honest, this is more or less what they look like, right? So this is an ER diagram we find frequently, I'd say, or more frequently than we wish. This could be me, right? And this could be Sergi getting ready to face the schema with me. So we kept thinking, what if we could save a couple of weeks of work of an ETL engineer? What if an automated system could do at least part of this work? So what we've been working on is what we call the fetcher, okay? Which is a script that will give me candidates for tables and columns that I'm looking for, right? What does this fetcher do? So first thing is, we thought, how do humans think while approaching the problem? What do I think when I approach the problem? So I know that ticket and ticket products are usually the largest tables. So the first step of this fetcher is very simple. It's just a bunch of imposed rules, and I go on narrowing down the candidate tables to be my ticket, the candidate tables to be ticket product, and so on, okay? I know the ticket table must have a timestamp, so great. Every table that does not have a timestamp, I know it's not my ticket, and so on. So this first step is a bunch of imposed rules. Then we borrow a concept from thermodynamics, which is entropy, which is a measure of uncertainty, to help us look for candidates, for column candidates. So I have a table which is a candidate to be my ticket, but I can't tell which column is ID, which column is billing. How do I face this problem? Just a second. Okay, so to understand this, I'd like you to think of two different scenarios in which I can either live or die, right? Would you rather watch me cross the street or play Russian roulette? Which would be more exciting? Well, watch me play the Russian roulette is much more exciting, right? Maybe too exciting. And why is that? Well, that's because playing Russian roulette, you don't know what's going to happen, right? So if we said that entropy is a measure of uncertainty, which would you say has higher entropy, playing Russian roulette or crossing the street? Well, if you watch me play Russian roulette, every step of the way, you learn something, right? She didn't die. What's next? Thank you very much. I love the laughter. Okay, so now watching someone cross the street, you're like, yeah, whatever, I know she wouldn't die. Not fun, right? Okay, so let's look at something a bit less extreme. Let's think of tossing coins. So if you toss a fair coin, you know there will be 50% probability of getting heads, 50% of getting tails, right? Let's compare it with tossing a biased coin, which only gives you head, okay? Which one has higher entropy? Fair coin, right? So if it has more uncertainty in these terms, so the fair coin gives me high entropy. In this case, maximum entropy, right? So if we look at the fair coin, and you see this is entropy, and this is probability. So I have probability 50% here, that's 50% heads, 50% tails. I have maximum entropy in this case. If you're into the maths, like my friend Alberto, you want to see proof of that, and here you are. Okay, so entropy is 1, which is maximum entropy in this case because we have 2 possible outcomes. Okay. Now, if you look at entropy of the biased coin, you will see, well, there's no uncertainty at all, which means entropy is 0. Okay. By the way, if you wanna calculate entropy of one of your columns, one of your features, for example, and you don't want to do it manually, here's a method in Python you can use, okay? How does this help me find my columns in tickets? Well, the thing is, if you calculate entropy for each of the columns you have, so imagine what I'm trying to do is, here I'm telling you, this is ID, this is billing, this is customer ID, but my script, my fetcher doesn't know it. So what I tell it to do is, it calculates entropy for each of the columns, and of course it normalizes so I can compare them, and then you will see, well, the IDs, well, IDs are unique, so I have maximum entropy in the case of IDs. Very easy to spot the ID in ticket. Okay, what do I expect my billing entropy to be? Well, it depends on the kind of client I have. If it's a shop, for example, that sells products, any products in grams or meters, for example, I expect entropy to be very high. What does it mean? Well, it means that I expect these numbers here, these possible outcomes to be very different. I know it won't be 1, or I guess it won't be 1 because, well, there will be some values repeated, but I expect it to be very high. Now, depending on the industry we're working with, so say fashion, I expect the fashion industry to have a billing which is lower than this. Still high, I'd say, but lower. Why? Because, well, the combinations of price of product and quantity, they are kind of limited, so these values are going to be repeated. So I know more or less what to expect, and these numbers help me make better guesses, let's say, of which column is billing, which column is customer ID. Seller ID, for example, I expect it to have low entropy. Why? Because, well, shops don't have so many sellers, right? So I'm going to have IDs repeated a lot of times here. Customer ID is really tricky because it really depends on how much a shop collects their data. So I'd say this shop, for example, they collect a lot of their customer IDs for every purchase, but it really depends on how they do it. So this is one of the things that we are using to help us distinguish the columns. There's one more thing, and I hope you believe me. It's called Benford's Law, and when Sergi told me about it, I was like, really? And then I told a bunch of friends, and they said, really? And then anyway, I decided to tell you. So it's the law of first digits. What is this law of first digits? Well, so back to probability. If, for example, I get the first digits in every number that there is in this ticket, okay? Only the first digit. What do you expect the distribution of these first digits to be? So from 1, we don't consider 0, from 1 to 9, what do you expect? We say, well, these are random numbers, so I expect the distribution to be, well, they should, it should be even, right? Not really. So according to Benford's law, the first digit, 1 as a first digit, is much more probable than 2, which is more probable than 3, and so on up to 9, okay? And then you're like, no, you must be kidding me. The secret here is, this happens for naturally occurring numbers. I know, Theo, I know what you're thinking, I've been there. So this happens for naturally occurring numbers. And so you can go to Wikipedia, for example. This is the distribution of the first digits in the population of 237 countries, okay, in July 2010. There's some noise, but, well, let's say this fits very well, right? Benford's distribution. And then we ran it here, right? So there's this this library, Benford Pi. We ran it here, and what you're looking at is the distribution of billing of a shop. Again, some noise, but it's there, you can see it, right? It does make sense. Now, if I plot the distribution of non-naturally occurring numbers, in this case ID, so I have ticket ID, product ID, distribution is completely different. And there you go. So it helps me find which are naturally occurring numbers, which are not, and gives me ideas on which columns I'm dealing with, okay? First achievements. So we estimate a 50% reduction in the time we spend in data wrangling, which is quite something, right? Bonus track here, besides the factory origin validation in these scripts I mentioned, we have also worked on an ETL framework which allows us to work on the raw import and this transformation step in a very easy way. So we have all the methods, or most of the methods we need in this framework, and all we have to do, if you can see it and understand it, is you have to fill in a configuration file, okay? You have to say, okay, which table am I looking for in origin, in my client's database? Which columns do I want? What function do you want to use to extract? Function you want to use to post into S3. This is the raw import, for example. And all the transformation steps. So this is something that has reduced quite a lot the time we spend in this process too, right? What are next steps? Well, so we know we want to improve the fetching algorithm, right? This is, we have just worked on a phase 1 and we are happy about it, but we know we have to improve it. And ultimately, we would like to close the cycle so that the algorithm can learn without human interaction. How do we want to do it? Well, this is an idea, right? Using reinforcement learning, in which the fetcher would be the agent. The action then would be this fetcher filling out the config file for the raw import and for the transformation, so we don't have to do it. But then, of course, what the fetcher has is candidates, right? There are some possibilities. So the idea is it would load into our database all the possible combinations it has, and then our Moises would validate it. You don't have to be here, that's the magic of it, right? So our internal validation script, which would be the environment, would give the fetcher back a state and a reward, so it would learn by itself, right? This is what we would like to achieve. We know there's a library, GIM is a framework to implement reinforcement learning algorithms, and that's an idea. Right? To wrap it up, then, what I've learned from all this. So I have to quote the masters, right? At some point, Alberto we were looking at plots, and we were talking about data quality and how this data comes to us. And he looked at a plot and he summarized what I had in mind so perfectly that I will keep on quoting you if you allow me, everywhere I go. So he said it seems that there's one way to do it right, but so many ways to mess it up. He didn't say mess it up. That's the good one to give today. Yeah. And then, well, it's true, right? So we know how we want shops to collect their data. We know how we want them to organize it. But there are so many ways to do it wrong, right? It can go wrong in so many ways. And the same thing for us. Like, it can go wrong in so many ways when we work on the transformation. But the nice thing is, once once first you know the business and you have seen a bunch of ways of how you can do it wrong. I usually say everyone is a good example. Some people are a good example of what you should do, some are a good example of what you shouldn't do, right? But these are all very good examples. So once we've seen a bunch of scenarios, we can look for automating these steps. Then something else I've been learning, and it's very clear now, is that data science is not only about machine learning, right? So I mentioned machine learning like as a next step, but I have to say I consider what we've been doing is data science because, well, we've been bringing concepts from other areas, which is not only machine learning. And this means when we do get to machine learning, we will have something meaningful already, right? So you have to learn what's surrounding machine learning so we can connect the dots. And finally, to quote another master, when we first talked about the fetcher, Sergio said, well, it's fiction, huh? I'm gonna tell you, I have this idea, it's fiction. And then, some months later, he said, well, remember, it started as fiction, now it seems to be science fiction, let's see which word we keep, right? So that's it. Thank you very much.
There is any question?
Yeah.
Now, this is a curiosity. You say that you have to perform a lot of internal validation, no, to see that the total of the tickets.
Exactly.
As this comes directly from a point of sale, it's pretty usual that this sums doesn't add up.
Unfortunately, you'd be surprised. That's the first question I asked, actually, right? You say, is it possible? Is that even possible? Yeah. It's real life, right? Unfortunately, it's real life. Well, things can go wrong, right? We understand things can go wrong. Sometimes wrong for good, but well, that's it. Anyone else? Well, we can talk at the end. Yes?
When you talk about the naturally occurring numbers, any number that you find about any statistics of the world, or
Yeah, if they are naturally occurring, right? And then of course,
not computer generated?
yeah, if they are completely randomly generated, then it doesn't apply. Yeah, there are certain rules for you to understand. And then of course you need to get a good sample, right?
But it applies to it.
It does. Yeah, it does. I know. It's a bit disturbing. I'm sorry about it. Yeah. It's like wow. Yes, I know. Okay. Yeah.
When you talk about the entropy, and what you said that depending on the store or the data you have different values of that differentiate the columns.
Exactly.
Do you have a way to adapt if suddenly like store or a client suddenly changes the way they operate or they decide to do something completely different?
So the thing here is we're using it to select candidate columns, right? Of course, there is a risk that we are dealing with a shop that deals with that information that behaves completely different from what we've seen. So the risk here is the fetcher will choose a candidate that is not good. And then, well, fine, like we will find out. So we are on this way of applying a lot of techniques to coming down to something that is good. But it's true that it depends a lot on the behavior of each shop. And then we need aid from different techniques. This is one of the things that can help us. But
so this process of selecting columns, is it possible that you apply a machine learning algorithm instead of calculating entropy?
well, I believe so. There are so many ideas out there. Like these are first steps we've been taking. But I'm sure if we sat down, we would think of machine learning algorithms. Like there are a bunch of options out there. We have decided to start simple before trying any machine learning algorithms. So this was the whole point, right? Seeing what we can do before.
But actually, if you're using entropy, it's kind of like machine learning simplified.
It's an algorithm, right?
But it's not.
Yeah. It's not the usual, but well. Okay. Yeah.
Have you noticed any, so from the columns that have high entropy, have you noticed any relations like this column is causing the entropy of other columns? Like the
No.
related variables, maybe the high entropy in one column is because of the high entropy in another column?
No, and you know what? This is something that's a very good point, because this is something that we discussed in the beginning. Like the very first thing I worked on with BigFi was looking at data quality of these shops, and we wanted to understand exactly that. Like, do shops that collect customer, for example, also collect seller? And the thing is, well, of course, there are some that do, but usually, like, it's very difficult to find the perfect data collection, right? So they mess it up in some way, you know? So I can say that this is always related to that. So, of course, depending on the shop, there is a correlation, but it doesn't apply to all of them. So it's really tricky. Yeah.
It's related, but we also looked at the relationship in tables, like primary peak, market peak, because you probably think it's kind of the way the relationship between is different tables. How
So-
put it in a graphic system.
So this is one of the things we do in the imposed rules. I don't know if that's what you mean, but in the imposed rules, one of the things we do is, of course, like my ticket is related to my ticket product, table. So I know that the IDs that are here must be here. So this is one of the things we are looking for. Okay.
But I mean, like, there's, I think, because the point of sale probably already has built-in, schema, so you already know which ones are private keys, foreign keys.
Okay. I see your point.
Sometimes I don't know even that.
Exactly.
It would be one good way to approach the problem would be to put everything into a graph and go for investing more.
And because usually the structure would be very similar,
Yeah, exactly. We are really thinking of situations in which we have very little information from them. And this is the case sometimes. We have very little information from them. So we go on finding other ways, our own ways of dealing with it. Yeah? Okay, thank you very much.
Thank you.